Alright, now it is time for an exercise, and this one is about the tests for normality in R. For this exercise you would have to load the dataset diamonds, so it's called diamonds, and please be aware that for this dataset you need the library ggplot2. So if you do not yet have this very useful plotting package, please install it now. It's called ggplot2 and I highly recommend it. It is also part of my Graphs in R course. Alright, so you would get familiar with the diamonds dataset, and the question is now, what does the column depth tell us? So it is all about the variable depth. After that, you would perform at least two different graphical tests for normality. And at last, you would get familiar with the package nortest. So you already heard about the Anderson-Darling test, and this test was part of this package nortest. But there are some more very useful tests for normality in that package, and now it is time to get familiar with those other tests and how the commands for those tests actually are. And you would now perform at least 3 different tests for normality. Just a little hint, if you want to do the standard Shapiro-Wilk test in the base package, you would have to draw samples from your dataset. The Shapiro-Wilk test only can handle 5,000 observations. So there was just one hint in case you want to use the Shapiro-Wilk test. Alright, please stop this video now because I am now going to present the solutions to you. Good, so the first thing we need to do is we need to load ggplot2. After that I'm getting the head of this dataset and I'm attaching it also for easier processing. So as you can see, we have all those variables down here and we are interested in this one called depth. If I'm now going to the help section for this diamonds dataset, I can take a look what depth is and how it is calculated. So depth is about the total depth percentage, and it is calculated with z, x and y, and those are those 3 values up here. So briefly spoken, it is some sort of a static parameter of diamonds. Alright, let's at first take a look at graphical tests for normality. We could plot a QQ norm plot. And as you can see, this one looks quite curvy. So this is not exactly what we are looking for. So we now have one negative graphical test. We can also get a look at the histogram. And this one does also not look like a real normal distribution. So now I'm getting already a bit suspicious that this dataset is probably not normally distributed. So therefore I am now starting the normality tests. Since the first test I want to conduct is the normal Shapiro-Wilk test, and I know that this test can only handle 5,000 observations, I need to sample this dataset. Therefore I'm creating the object depth small, and this equals a sample from the vector depth of 5,000. So this actually draws 5,000 random observations from these over 40,000 observations in the depth vector. So I'm running this line, and now I have this depth small object, and with this one I can now run the Shapiro-Wilk test or Shapiro.test. And as you can see, I'm getting a highly significant p-value. So it again looks like this depth dataset is not normally distributed. And now we can actually take a look at the nortest package. And this one actually contains quite a few tests for normality because that is the main purpose of this package. The first test we could run is, for example, the Kramer von Mises test. So it is cvm.test, and I'm running this one. And as you can see, the p-value is also highly significant. So we have one more score towards non-normality. We can actually ignore this kind of warning message down here, which says it cannot compute a more precise p-value, but this output here is precise enough for us. The next test we can run is the Lily.test or the Kolmogorov-Smirnov test. In R, we can run this one with a whole depth vector, and we again get a significant p-value. The next test we can run is the Shapiro-Francia test or SF.test, and since it is again a variety of the Shapiro test, we need our small sample with 5,000 observations. So we run this one and we again get a significant p-value. So this was now the third test from the NOR test package, and the last test from this package is the Pearson test or Pearson.test. We can use it for the whole depth vector. Then running this one and I'm again getting a significant p-value. So those were actually more than enough tests to state that we can reject the hypothesis that this dataset is normally distributed. So therefore, for all the other tests we would now run with that dataset, we would use non-parametric tests. Or we could also do some kind of logarithmic transformation with that dataset. I hope that you enjoyed this exercise and that you also got a bit more in-depth knowledge about the NOR test package, which is a really useful package for tests for normality.